This is session 8 of this course, and in this session I'm going to talk about controlling extraneous variables. Remember, in session 7 I talked about extraneous variables. I identified 3 main types and talked about them in detail. So in this session I'm going to talk about why it is necessary to control these extraneous variables. Usually, discovering problems with internal validity of an experiment after you have collected your data or conducted the experiment may be too late. That is why when you are designing your study, you have to be aware of any possible extraneous variables and see how you can control these extraneous variables as you collect your data. So a poorly designed experiment cannot be fixed later. So you make sure that your design incorporates controlling extraneous variables. So by the end of this section, you should be able to explain why it's necessary to control extraneous variables in experimentation. You should be able to discuss the 3 basic techniques for controlling extraneous variables. Again, you should be able to describe the various ways in which participant effect and experimental effect can be controlled. And in all of this, you should be able to say how, if you control these extraneous variables, internal validity can be achieved. So I'm going to cover 3 main topics: the basic control techniques, control of participant effects, and control of experimental effects. And this is your reading list from Christensen 1997 and Christensen 2000. So read these pages in these textbooks. So let's look at basic control techniques. As I mentioned earlier on, discovering problems with internal validity after you have conducted your study is too late. Once you have conducted the study, you cannot fix any threats to internal validity. So it's important that, as I mentioned, while you are designing your study, you think about the possible extraneous variables that can confound your experiment and then try to control for them as you collect your data. So the first one is randomization. I've mentioned this as I've gone along in some of the sections. So according to Christensen 2007, this technique equates groups of participants by ensuring every member has an equal chance of being assigned to any group that is involved in the experimentation. So if, let's say, we have two groups of participants, we have the experimental group and the control group, randomization ensures that if we have 30 participants, each of the 30 participants stand a chance of being in any of the 2 groups. So randomization is the most important and basic of all the control techniques. And it is the only technique that is known to control unknown sources of variation or unknown extraneous variables. So what this means is that if, let's say, age can act as an extraneous variable, so how old you are can affect the outcome of a study, and age is not our independent variable, when we randomly assign participants to the various groups, we have the likelihood of having perhaps the 2 groups that are involved having people with similar age ranges. So randomization allows internal validity to be achieved. Now, when I talk about the fact that it affords each participant a chance of belonging to any of the 2 groups, let's say we have 30 participants and we have 2 groups that we are testing. So to randomly assign them to the 2 groups, what we do is that we can decide to write the figure 1 and 2 on pieces of papers, and we ask them to pick. So all those who pick figure 1 will be in the first group, and those who pick 2 will be in the second group. So it means that anybody can pick 1 or 2 at any time. The second basic control is matching. This is using one of a variety of techniques to equate participants on one or more variables. So Variables which participants are matched on are controlled in order to maintain or achieve consistency. So matching can be done in various ways. Now let me give you an example in order to understand this better. So if age can be an extraneous variable in our study, then we will match participants on age. And matching, as I said, can be done in various ways. One of the ways is by holding the variables constant. So matching can be done by holding the variables constant. So the experimental controls for the extraneous variable by holding them constant for all groups. So participants in all the groups will have the same degree or type of the extraneous variable. So for instance, if we want to study the effect of group cohesion on conformity, so we have two groups of participants. One that would have where there's group cohesion, and another group where there's no group cohesion. And what I mean by group cohesion is, let's say, for example, I have a group of participants and then I give them something to read about a particular event. And then they read this passage and they are supposed to form their opinion about it. So we have a couple of participants who have a negative opinion about what they have read. And then they have a lot more. So let's say there are 30 of them. 2 people have a negative perception about what they have read, but the other 28 are people who have a positive perception about what they have read. So as they do the discussion, with time, we want to find out if these 2 individuals would change their perception and make it a more positive perception like the 28 other participants. So if they change their perception, then we would say that the group has been able to coerce these individuals to change their perception. Then we have another group where we don't have the group trying to influence the perception of the participants. Now, studies have shown that gender, being male or female, can affect the extent to which people conform to group cohesion. So in this case, it means that sex is an extraneous variable or gender is an extraneous variable. So we hold that constant by making sure that we test only males or we test only females. So if we have 2 groups of participants, we have all females in one group and all females in another group. So in this case, we have held gender as an extraneous variable constant. Now, if we want to match by building the extraneous variable into the design, what it means is that, for instance, if we think that age is an extraneous variable, IQ is an extraneous variable, etc., we may choose to group our participants according to their level of IQ or according to their age ranges. So in this case, we have built the extraneous variables into our design. So these are extraneous variables we've built into the design. So it's quite different from the independent variable that we will be manipulating. Again, we can also match participants by equating them on the extraneous variables that will affect the outcome of the study. So again, if it's IQ or gender or age, which we think that will affect the outcome of the study, what we do is that we group the participants according to their ages, according to their IQs, according to their gender, etc. And then the next step will be to randomly assign these groups to the groups that we are interested in. So let's say that we are comparing an experimental and a control group. So we group participants according to gender. So if we have males, 30 males, we are randomly assign them to the 2 groups. So we have 15 in each group. Then if you have 12 females, we randomly assign them, so you have 6 in each group. So in this case, you are equating the participants based on gender. Or if it's IQ, we have people with IQ of 100, and there are 10 of them. We randomly assign them to the 2 groups, so that again, IQ is equated among the groups. So this is matching. This is how we match participants to control extraneous variables. Another basic control is counterbalancing. Remember when I talked about the within participant design, I mentioned that the main challenge with this design is the sequencing effect. So counterbalancing is used to control sequencing effect. The various treatments of the experiment are assigned in different orders for different participants in order to reduce the sequencing effect, so that if it is the sequence with which we administer the various conditions that is affecting the outcome of the study, that is controlled for. Now we can have complete counterbalancing and we can have partial counterbalancing. I'll explain the two. With complete counterbalancing, it provides every possible ordering of the treatment and assigns the participants to each of these orderings. So I'll give you a practical example. If, let's say, we have just 6 participants we are testing and we have 3 treatment conditions. So let's say we are administering alcohol. So we have 1 bottle for the first order, 2 bottles for the second order, and 3 bottles for the third order. So each of these participants will receive a different order in which the alcohol is administered. So looking at this example, participant 1 will have 1 bottle, then 2 bottles, then 3 bottles. And after each order, we measure the dependent variable. If you take participant 3, for example, participant 3 will first have the second order, which is 2 bottles, then have the first order, which is 1 bottle, and have the third order, which is 3 bottles, and it goes on like that. So each participant with complete counterbalancing, each participant receives a different order of the treatment that is being administered. We can also have partial or incomplete counterbalancing. And notice the word partial. What it means is that in this instance, we cannot have each of the participants having a different order or different sequence of the administration of the independent variable. What we have is we have groups of participants who will have different orders of the independent variables. So imagine we have 6 participants and we have 3 levels of the independent variables. It means that we'll put our participants in 6 groups. So this is how it will look like. We have 6 groups of participants. So the first group would have the first order, the second group will have the second order, etc., etc. So for each group, we have 4 participants who will have a particular order, just to counterbalance the order so that sequencing effect will not set in. I'll give you another example. If, let's say, we're administering questionnaires, again, with that one, you can have sequencing effects occurring. So if, let's say, we have 5 different types of questionnaires, we have arranged them in an order. So we have a questionnaire that is measuring stress levels. We have one that is measuring how people cope with stress. We have one that is measuring self-esteem, another measuring maybe depression, and another measuring anxiety. So we have 100 participants. So the first 50 participants will have one order. And then we reverse the order. So first of all, we may choose to say that in one order, we have 1 to 5 questionnaires. And then in another order, we will reverse the order of the 1 to 5. So now 5 becomes 1, 4 becomes 2, etc. And then we reverse this order for the next 50 participants. So in this case, we are trying to control for sequencing effect. We vary the sequence with which the participants respond to the questionnaire. So these are the 3 basic techniques. Now let me talk about the controlling participant effect. One way of controlling participant effect is testing and weighting participants. And what this means is that unweighted participants are generally participants who are not aware that they are being observed for an experiment. So, for instance, we are observing consumers in the supermarket. We use a hidden camera. So these participants walk in and out of the supermarket, not knowing that they are being observed. Then we have the use of deception. So usually in experimental research, it is not allowed that you use deception in your study, but there are instances where experimenters would use deception and in these instances, they have to justify that the only way to be able to conduct the study is by using deception. So sometimes, so that the experimenter does not give away the hypothesis of the study, for participants to form their views about the study, the experimenter will use deception. So participants will think that the experiment is studying one thing when in fact it is studying something else. So let's say we want to study healthy eating among students to determine whether to determine the eating pattern of people who are obese and people who have normal weight. Now, if we told students that this is what we are trying to find out, obviously perhaps those who are obese will respond to our questionnaires to show that actually they are healthy eaters. It's just that they are people who are generally just overweight. So in this case, we use deception. So we tell students that actually we want to find out whether the type of food that is being sold, let's say at the night market or what you call the bush canteen, where students will buy food from. So we want to find out the kind of food that is being sold there and the kind of food that students usually patronize, so that we'll see how we can improve upon the conditions there. So in this case, we've used deception so that participants will not know that we're actually assessing whether they eat healthily or not. So this is one way of controlling for participant effect. Again, we can use what is called the double-blind technique, where neither the participant or the experimenter is aware of the treatment condition. So what sometimes happens is that if participants know that they are in an experimental group, they may behave in ways to help confirm the hypothesis of the study. So let's say we are testing a sleeping pill and we give the sleeping pill to the experimental group, and the experimental group knows that actually we have taken a sleeping pill. What is likely to happen is that we give them the pill, and after a couple of hours they may pretend to fall asleep even if the drug is having no effect on them. So in this case, we blind the participants. So you have an experimental group, you give them the pill. You have a control group, you also give them what you call the placebo, which is a pill, but it's an inactive pill. So both groups knows that they are taking a pill. They don't know which pill they are taking. So they are blind as to what condition they are in. In fact, they don't know whether they are in the experimental group or the control group. All they know is that they are being given a pill, and then they are being assessed based on that. Again, the experimenter is blind as to who is the experimental group and which one is the control group. So what this means is that the experimenter will have a third person who will administer the pill, the active pill and the inactive pill to the two groups. So both the experimenter and the participant are blind as to knowing who is receiving which treatment. So who is receiving the placebo and who is receiving the active drug. So what happens is that the experimenter will do the manipulations and give these drugs to a third person, as I said, to administer the drugs. Another way of controlling for participant effect is the single blind technique. So we have the double blind, where neither the experimenter or the participants know who is receiving the active treatment. Then we have the case where it is only the participant who is blind. So participants do not know whether they are in the experimental group or the control group. And that way, they will not make responses that they think that the experimenter expects them to make. So now let's talk about controlling experimental effects. One way of doing that is by using well-trained experimenters. So basically, when you use well-trained experimenters, you are able to control for experimental effects. So you train the participant, because the experimenters are trained, they are able to behave consistently among the various groups that they are testing. Again, you can also control for the recording of errors. So sometimes the recordings that the experimenters make may have errors in them. So one way of controlling And of course, if there are errors in the recordings that are made of the dependent variable, it affects the outcome of the study. So in this case, what happens is that you ensure that the experimenter will make careful observations in order to have accurate data. What you can also do is to have multiple observers. So if, let's say, it's a study that involves observing consumers or observing children in a playground, you have more than one observer or more than one recorder who is observing and recording the behaviors, and then you can compare that across the recorders. One way of also controlling experimental effects is by automating, for example, the instructions that are given to participants. So instead of having the experimenter come in and give the instructions, and I mentioned earlier on that sometimes the experimenter may give the instructions in a different way than he or she will give for one group compared to the other. So because the experimenter is expecting a change in the experimental group, they would give the instructions in a certain way to help confirm their hypothesis. So when you automate the instructions, you may just perhaps record the instructions and just play it. So these instructions are consistent for all the groups that are involved. You can also automate the recording of responses that participants make. And then finally, again, you can use the double-blind technique. And here I'll refer you to the slide 20 and 21 of this session, where I have explained what the double-blind technique is. Finally, you can control experimental attributes by using the same experimenters in all the conditions. So you use the same experimenters for the experimental group and the control group, etc. So this is the end of section 8, where I have talked about controlling extraneous variables.